Okay, so I want to share with you guys one of, in my opinion, the most interesting and fun and elegant formulas that you can possibly use in math. It's definitely not the most complicated, but it certainly is my favorite. And we call this thing the Pythagorean theorem. Okay, we call this the Pythagorean theorem. And it's my favorite because it's very useful when I'm trying to find missing sides or, and eventually missing angles. But right now, at least missing sides. And so what I want to do first is I want to label all of these pieces of a triangle so you know what I'm talking about. And then I'm going to show you how to actually use Pythagorean theorem. Okay. So let's assume, let's just assume that we have this right triangle here. And let's talk about the different pieces. So I'm going to start with the fact that a right triangle is a triangle that has a 90-degree angle. So if you look at this corner here, you should hopefully have seen a right angle before. That's 90 degrees. And when we're talking about a right triangle in particular, okay, we have these two sides A and B here, and we call these two sides legs. Okay, so we're gonna call them legs. All right, so side A and side B are both legs, and essentially those are the two sides that form the right angle. Two sides that form a right angle. Okay, at least in a triangle, right? So we're talking about the sides that are forming the right angle here, and these two are the legs. And they're typically the shortest and then the second shortest. They're usually not the longest. The longest of the two is always going to be the side across from the right angle, right? And we call this side the hypotenuse. Hypotenuse. And this is always the longest side. Okay, and it's the longest side across from the right angle. Longest side across from right angle. Okay, so we've got the two legs here. We've got leg A and B, and then we have our hypotenuse. Okay, so that's what we're talking about when we're actually, discussing the triangle. But let's assume for a second, let's assume that I knew the measure of side A, and I knew the measure of side B, and I wanted to know the measure of side C. Okay, so I have A, I have B, and I want to know C. Okay, the Pythagorean theorem allows me to take the square of A. Okay, so the Pythagorean theorem, okay, allows me to take the square of A, of the measure of side A, add that to the square of side B, and the two of them together should equal the sum of these two should equal the measure of side C squared. Okay, so A squared plus B squared equals C squared. That is the Pythagorean theorem. Okay, that's our big deal here. All right. So A squared plus B squared equals C squared, and that is huge. Okay, it's immensely useful because I can pretty much find, if I have two of the sides, I can find that third side no matter what. If I have C and B, for example, I can find A. If I have A and C, I can find B. If I have A and B, I can find C. Okay, that's huge. All right. So it's the sum of the squares of the lengths of the legs, so A squared plus B squared, and that's equal to the hypotenuse squared. Okay. So let's assume now, let's assume that A, okay, let me show you how this works. Let's assume that A is equal to, let's assume it's equal to 3. Why don't I draw another triangle here? Let's assume that A is a side here. Let's try that. Okay, and then we'll make a triangle here like this, and then something like that, right? And we're going to assume that this is a right angle, okay? And side A, right, is corresponding to this one. So let's say that we have a side that's a size of 3, okay? And then let's say that we have a side of 4, and we'd like to know, okay, we'd like to know what the side here is. Let's call that, we'll call that C. Why not? Let's call that C, okay? So we have 3 and 4, we have A and B, and we'd like to know what C is. So what we can do is we can plug these numbers into our equation, our Pythagorean theorem, and we can solve, okay? So let's take A, right? So let's use A, or 3, right? We'll take 3 squared, and we're going to add it to B squared, which is 4 squared, okay? And that should equal our C squared, okay? Now we can do that 3 squared, right? If we just take it down here, 3 squared, 3 times 3, which is 9, plus 4 squared, which is 4 times 4, which is 16. And that's equal to C squared. And then if we add 9 and 16, we have 9 plus 16, which we get as 25. And that should be equal to C squared. Okay? Now, our answer is not necessarily C squared, okay? It's not 25, because we're not looking for C squared, we're looking for just plain old C, right? So we have to get rid of the squared somehow. And we can do that using a square root, okay? So we'll take that 25 equals C squared, and I'm going to find the square root of both of those terms, okay? Because whatever I do to one side, I want to just get C here, I have to do the other, all right? Now, if we take the square root of C squared, we just end up with C, because these two cancel out, right? We have this 2 here, and those two cancel out. And then the square root of 25, well, if you've practiced with square roots before, you know the answer, but we're trying to think about what fits into 25 twice if we're multiplying that number by itself. Okay, so the only number, right, if we do 1 times 1, right, we just get 1. If we do 2 times 2, right, we get 4. 3 times 3 equals 9. 4 times 4 equals 16. And then 5 times 5, we know, gives us 25. So the actual answer of C should be a 5. Okay, so C over here is going to equal 5. All right, and this is actually a triangle that you'll see fairly often. You'll see this 3, 4, 5 triangle, and that's kind of the most basic example of Pythagorean theorem that you'll see is a 3, 4, 5 triangle. Okay, but that's how you actually use the Pythagorean theorem. You have to plug in the sides that you know into the variable that you have, and then you have to actually solve. And you'll have to take the square root no matter what, because all of these terms are squared. You'll have to take the square root. Okay, you can start solving the equation like that. Let's do one more triangle. Okay, let's do just one more triangle, and let's see if we can figure this out. All right, so I'm gonna try this tool again, and we're gonna try to make it line up here the right way. All right, and we're again assuming that this is a right triangle. Pythagorean theorem, by the way, in this case only works with right triangles. Okay, so this doesn't work with something like an isosceles triangle unless it's got a right angle in it. All right, like a scalene triangle doesn't work. This one has to have a right triangle, right, or at least a right angle in it, which makes it a right triangle, right? So you can't use it in anything else. And let's say that this side is our A, right? We'll say that's 12 inches. And then let's say that this is 9 inches. Okay. And I encourage you to actually take a second and try to figure this out for yourself. So assuming that you have, what we're going to do is we are going to take 12 and 9, and then we're going to try to find the missing the missing side here, x. Okay? So we're going to plug that in, right? Let's take 12. Let's do this. We're going to take 12 first, and we're going to have 12 squared. We're going to plug it in just like we had here. We're going to add that to our second number, which we have is 9 inches, right? We're going to take 9 inches squared, just 9 inches squared. And that should be equal to our x, the value of x squared. Okay? So let's take 12 squared. If we do 12 times 12, right? 12 squared gives us 144. Okay, 144 plus 9 squared, 9 times 9 we get is 81. 81, right? And that should be equal to x squared, the sum of those two. So if we take 144 and we add 81, right? If we in the ones place, we're going to get a 5, right? 1 plus 4. And then in the tens place, we got 8 plus 4, which we get 12, which means we have to carry that 1, and 1 plus 1 gives us 2. 225 should equal x squared. Now remember, we have to take the square root of both sides because we don't want x squared, we want x. We have to get rid of the squared here, which means we have to get rid of the squared over the 225. Okay? And if we take x squared, we're going to just get x. So we'll move up here now. We're going to just get x. And then if you think about the square root of 225, right now we had 5 times 5 here was 25, 6 times 6 is 36, right? We can think about that. 10 times 10 gives us 100, right? So we're getting a little bit closer. We know that 12 squared is 144, right? So we can do 12 times 12. And you can actually think about that too, right? If you think, well, I know that x has to be the longest side, so it's got to be greater than 12. It has to be greater than 9, and it has to be greater than 12. So we know that 12 squared gives us 144, right? 13 squared, 13 times 13 gives us 169. Okay. And then we have 14 squared. 14 times 14, which is 140 plus, let me check to make sure my math's right? You get 100 and something, right? 4 times 4 is 16, carry the 1, then you get 5, placeholder, and then you have 4 and 1, so I think that should be 196. So we're getting a lot closer, right? Let's try 15 times 15, right? If you do 15 times 15, you get 5 times 5, which is 25. 5 times 1 plus 2 is 7. And then you have a 5 here and a 1 there. That's the sum. 5, 12, and you get 2. So your answer for this question is that x is going to be equal to 15 inches. X is going to be equal to 15 inches.